Hey everyone, today we are going to be placing rational numbers on a number line. Up to this point they were just integers. Rational numbers opens up a new set of numbers that include decimals and fractions. So we are going to be placing fractions and terminating decimals on the number line. So just as a quick review, the decimal equivalent, remember we need to have, of each fraction. So if we have a 2 in the denominator, we need a power of 10 to be able to write it as a decimal. So I'm going to multiply by 5 over 5. That way I have 10 in the denominator and I have 5 in the numerator. 5/10 is 0.5. Please try to do these two and then come back. Alright, again, hopefully you are actually doing what you're supposed to do and taking notes instead of just watching the video, and that you tried this. That's how you know if you are understanding or not. So here we had a 5, and so we needed an exact power of 2 to go along with that power of 5. So we multiplied by 2 over 2, which is 8/10, 0.5. Here this was already a power of 10, so we just needed to put the whole number in front of the decimal, and then 7/10. Now we'll do the opposite. This to me is easier, but you have to remember to simplify. So the fraction equivalent of each decimal. We say this 42/100. So you can go ahead and simplify in a variety of ways. Some people just keep reducing, so now I have 21/50. So I write it like this, instead of dividing by 2, I put my equal sign and put the 2 underneath, so I can think in my head 42 divided by 2 is 21, 100 divided by 2 is 50. Alright, this one is 3 75/100. I am hoping by now that you know 75/100, if you're thinking of quarters, is like 3 25. Nope, that's not what I meant to say. 3 3/4, because 25 goes into 75 3 times and it goes into 100 4 times. And this last one, we can say 36 and, now right here, this says 90/100, but we really don't need that 0, so I'm just going to go ahead and simplify to 9/10. The end. Alright, let's see what's new. We have spent time locating opposites, so we know that opposites are they're the same distance away from 0, but on opposite sides of the 0. So if we have to locate and graph 3/10 and its opposite, if this is 0 and this is 1, we need to break this down into tenths. Very similar to if you had 1 centimeter and we wanted to break it down into millimeters. So pause and break your number line into tenths. So 10 equal spaces here, 10 equal spaces here. Alright, so mine is not perfect, but when you are putting the hash marks, they should be equally spaced apart. So I'm not going to ding you if, like, I can see right here that this is smaller than this, but they should be about the same. So I'm not going to count off as long as I can see that you're trying to make them the same. So here's my 0, here's my 1. I needed something broken into tenths. So I have this broken into tenths, so this is like 5/10, which is the same as 1/2. 1/2 the distance between 0 and 1, and this is like -1/2. Half the distance between 0 and -1, but to the left. So if I was going to do 3/10, this is 1/10, 2/10, 3/10. And its opposite would be on the other side of 0, 3/10 away. And this would be -3/10. Right, this one is a tiny bit different because if we look at the fraction we're talking about, -7/4, it's an improper fraction. So we have to figure out between what two whole numbers is -7/4 and its opposite. Well, its opposite would be 7/4. So 4 goes into 7 one time with 3 left over. So we are trying to figure out where to place 1 3/4 and -1 3/4 on the number line. So think about that. What I would do is I would count my spaces and see how I could break this number line and number it so I could fit both of these numbers on there. So take a minute. You might want to start with 0 in the middle and then see how you could number it. See what you can do. So I numbered by counting by 4s because I had 4 in my denominator. So this would be like 1/4, 2/4, 3/4, 4/4, which is 1. 1 1/4, 1 2/4, 1 3/4, 1 4/4. Or I could have just numbered by 4ths. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and I could have done the same over here. Notice that this would be a -1/4, -2/4, -3/4, -1. So the further away we get from 0 to the left, the less the number is. So -7/4, -1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, which is the same thing as negative and 3/4. So I'm going to place a point there, and I'm going to name it -7/4, and it is 1, 2, 3, 4, 5, 6, 7 hash marks away, so I need to go the same distance over here to the right. 1, 2, 3, 4, 5, 6, 7. I'm going to put a hash mark, and that is the positive 7/4, which is the opposite. So on the number line, each segment would have an equal length of 1/4 of a whole, and the fraction is located between, and we're talking about the first fraction, -1 and -2. And the explanation would be, once it's in an improper fraction, we can see that it's between a -1 and a -2. Or you could say that since it is broken into fourths, when you have 0, you have to count by fourths. So 1/4, 2/4, etc. So make sure you write out your explanation, even though I'm just saying it out loud. All right, this next slide combines what we did yesterday with the whole idea of rational numbers. So I want you to take a moment to just read through and then see if you can answer the questions before coming back. Okay, so the lake rose 1.25 feet. So a rational number, if it rose, we know that it is going up. So we could say 1.25, but I also know that 1.25 is the same thing as 1 1/4. And since my number line is broken into fourths, I probably would start thinking of it this way. So what two integers is 1.25 between? It would be right here, so it's between 0 and 1. So the next thing we're asked to do is write the length of each segment on the number line as a decimal and as a fraction. So I just named the point. So I'm going to blow this up and I'm going to show you what I mean by that. So if we have it blown up and straight, this would be 1/4, which is the same thing as 0.25. So this here would be a -1/4, which would be a -0.25. Can you stop the video and please fill this out on your own and come back and double check? So again, this is a 0.25 and a -0.25, which is the same as -1/4 and a positive 1/4. So this would be the same thing as a negative 4/4 or -1. This is the decimal form. All right, for the sake of time, I didn't write them all out, but you can see that 0.25 corresponds with 1/4. So -1.25 is the same thing as -1/4. -1.5 is the same thing as -2/4, which is -1.5. So the further we go down, the greater this number is if we ignore that negative symbol. However, if we don't ignore the negative symbol, the further we go down, the less the number is. And then we could go the other way too. So after it rained, and we've already kind of done this up here, after it rained, if it went up 1.25, then the water level would be 1.25 feet. Oops. Feet. And we've already graphed that. Then we read the next question. After 2 weeks, the water level is now opposite of when it rained. So what is the opposite of 1.25? Well, we know that it's the same distance from 0, but on the negative side. Positives and negatives are opposites. So it would be a negative 1.25. And so I determine my answer because I know the opposite of positive is negative. And then I can go up to my graph and I can find that negative 1.25. So here's my -1, and it would be a quarter past that. So -1.25. It wouldn't be a quarter closer to 0. It would have to be further away from 0. All right. Last question on this slide, and the last slide actually. State a rational number that is not an integer. And that's kind of misleading because all rational numbers are also, well, integers are always rational numbers. Rational numbers are not always integers. So we need something that is not that has a part. If we want a rational number that is not an integer, we need a part, like a decimal or a fraction, whose value is less than 1.25, and describe its location between 2 consecutive. So this one, there are many, many, many different answers. So I'm going to give you one example, but for your notes, I want you to write a different example. I would say an integer that is less than 1.25 might be 0.75. 0.75 is between the 2 consecutive numbers, so it's between 0 and 1. So you think of a different one that is less than 1.25 and state which 2 numbers it is between. All right, that's it for notes. Please start your assignment. Let me know if you have questions. We out.